Hi everyone. In the given problem statement, we have to solve find peak element. A peak element in an element that is strictly greater than its neighbor. Given an zero indexed integer array nums, find the peak element and return its index. If the array contain multiple peaks, return the index to any of the peaks. You may imagine that nums of -1 equal to nums of n which is greater or which is minus infinity. So basically, let us take this example of 1, 2, 3, and 1, right? So here it can assume the value on the left hand side is minus infinity, making this value always greater, means the 1 or let's say whatever value would be there, right? It will be always be greater, and the value on the right hand side is always going to minus infinity. So this value is always going to be greater. Now we have to write an algorithm which runs in the big O of log n. So whenever we are getting a time complexity of log n, right, only way for us to solve it is using binary search. So a question might arise, right? This is a not a normal typical solution of binary search, right? The array is not sorted, nor it is in rotated sorted array, right? How we are going to check the values? So the idea, right, remains same of a binary search, right? We are going to have left and right, which is going to be 0 and length of nums -1, and let's say while our left hand side is less than or equal to the right hand side, and we have to find the mid. So mid would be L plus R double divide by 2. So right now the L is 0 and the R is 3, right? So the mid value would be 3 double divide by 2, which would be around 1. The mid value is currently this index. Okay. Now I'm going to check if the I'm saying that if left side is greater, left side greater. So in that case, what I'm trying to say, right? If nums of or left side is greater, right? So nums of mid is smaller than nums of mid -1. So in this case, right, if the nums of mid -1 is 1, right, it is not smaller. So we're not going to go in this loop. Or let's say we can write another condition. If right side greater, right side greater. So nums of mid is smaller than nums of mid plus 1. Okay. So in this case, right, the right side value is greater, right? 3 is greater than the 2. So what is going to happen, right? Our left pointer is going to increase by mid plus 1. So currently the mid value is 1, right? So it is going to increase, and our pointer, right, is going to be, the mid is going to get increased to sorry, our left pointer, right, would be out here for the time being. So it would be 3 plus 2 would be 5. 5 divided by 2 is going to be 2. So our mid is also going to be at 3. So once it is at 3, right, so I'm going to check, right, whether the left side is greater. So left side in this case, right, is not greater. Then I'm going to go to the if else loop, and I'm going to check whether the right side value is greater. Right side value is also not greater. So in that case, right, we have found a peak element which is 3. So I can say else return the mid value because it's a peak element. One thing that we are going to do, right, because here we are not, and in here, right, if it's the other way around, we just know it would be mid minus 1. We have to just check another condition. So if the mid value that we are getting, right, so if mid should be greater than the 0 for this case, and in the other case mid should be less than length of nums. So that would be the idea. So in this way it is going to work, and we finally able to find our peak element, which is 3, and we're going to return 3. That would be the idea. Now let us jump to the Python solution to get the results. So the first thing that we're going to do, right, we're going to initialize our left and right pointer. So left would be 0 and right would be length of nums minus 1. So I'm going to do check while our left pointer is less than equal to r, and we are going to find the mid. So mid would be left plus right double divided by 2, so that we get an integer point value. And now I'm going to check if, let me write it down, if left element is greater. So in this case, right, if nums of mid is smaller than nums of mid minus 1, so in that case what we are going to do, right, we are going to increase our right pointer. So it would be r equal to mid minus 1 elif, or let's say the right pointer is greater, or the right element is greater if right element is greater. So in that case, right, so nums of mid is less than nums of mid plus 1. So it would be left would be mid plus 1. And in case, right, if both left and right are not greater than the current mid value, then we are at the peak element and we can just return mid. There is one more thing that we need to do to check for the bound. So let me run the code. As you could see, it is giving the correct result. Let me submit it up. So there would be certain areas, right, where it is saying that index out of bounds. And the reason it is happening, right, because we do not have maintaining that bounding condition. So in order for us to maintain that, I can say mid should be always less than 0. Sorry, mid should be always greater than 0 for the first condition. And for the second one, mid should be less than length of nums minus 1, and it should be done this way. So let me run this code, and I hope this should work this time. So let me submit. As you could see, the code got submitted successfully, and it is beating 100% of the submission. So our code got executed in log n time complexity, big O of log n. So it's pretty efficient, and you're using a modified binary search to get this solution. That's all for this video. See you in the next one.